Hi guys, welcome back to my channel. So how do you solve this integral? So we are going to solve this integral by splitting this integral down using partial fractions. So let's dive right into it. So this one is 3x squared plus 5x plus 8 divided by x minus 1 times x squared plus 2x plus 5. And this one can be split into a over x minus 1 plus, this is a quadratic term, so the numerator should be a linear term. It is bx plus c divided by x squared plus 2x plus 5. And we can really expand the right hand side. So that is equals to a times this term here, that is x squared plus 2x plus 5 plus bx plus c times x minus 1. All this one divided by x minus 1 times x squared plus 2x plus 5. So the denominators are the same, so we just have to focus on the numerators. So 3x squared plus 5x plus 8 is going to be equal to ax squared plus 2ax plus 5a plus bx squared minus bx plus cx minus c. So we can group like terms. So 3x squared plus 5x plus 8. In the right hand side, we have a plus b all times x squared, because the x squared terms here are a and b. What about the x terms? So that is 2a minus b plus c times x. That is this one and this and that. And the constant terms, that is 5a minus c. So we can now compare our right hand side to the left hand side. So that is going to be a plus b, which is the coefficient of x squared in the right hand side. That is equal to 3. So that is equal to equation 1. The x term is going to be 2a minus b plus c, and that is equal to 5. That is the coefficient of x in the left hand side. That is equation 2. And the constant term, which is 5a minus c, that is equal to 8. The constant term in the left hand side. We can call that equation 3. So we are now going to solve these three equations simultaneously in order to find the values of a, b, and c. So from here, this equation 1 can find an expression for b in terms of a as 3 minus a, right? We can call this equation 4, and we can substitute that in here. So that is going to be 2a. In place of b, I'm going to write 3 minus a plus c, and that is equal to 5. This one simplifies to 2a plus a plus c minus 3 is equals to 5. And that sums to 3a plus c to be equal to 5 plus 3, that is 8. We can call this equation 5. And we can solve these equations simultaneously. That is equation 5 and equation 3 simultaneously. I can put that here, which is 3a plus c to be equal to 8. You can call this equation 5 as here. And we can sum these two equations together. When we sum them, the c and the c here will cancel, leaving 5a plus 3a, which is 8a, to be equal to 8 plus 8, 16. So in that case, a is going to be equal to 2. When a is equal to 2, I can find b from equation 4 here. So b here is going to be 3 minus 2. That is equal to 1. So we have found a value for a and b. So we are left with c. How do you find c? You can find c from here. So we know that a is 2 plus c is equals to 8. So in that case, c is going to be 8 minus 6, and that is equal to 2. So there we have our values for a, b, and c. So a is equals to 2, b is equals to 1, and c is equals to 2. These are the values of a, b, and c that will satisfy these three equations. So we can now go back up here to our partial fractions. A is 2 over x minus 1 plus b is 1, which is x, and c is 2. So that's x plus 2 over x squared plus 2x plus 5. So this is how our partial fraction can be split. So if we can't integrate this one, splitting it into a partial fraction like this, we should be able to integrate this one quite easily, right? Okay, so now let's perform the integration. So our integral I is now equal to the integral of x 2 all over 1 minus x. So that is the value of 2 here, 2 over x minus 1 plus x plus 2. So this one here is x minus 1 plus x plus 2 all over x squared plus 2x plus 5. All this one dx. This is now easy to integrate. Our integral is now the integral of 2 over x minus 1 dx plus the integral of x plus 2 all over x squared plus 2x plus 5 dx. So I is going to be the integral of 2 over x minus 1 dx plus, you can multiply the numerator by 2, which will get 2x plus 4, and divide the integral by 2. That we really haven't changed anything at all, plus 5 dx. So let's work with this. So the integral of 2 over x minus 1, I will integrate that later on, plus 1 half. This one, I can split the numerator into 2x plus 2 plus 2. That is 4 can be written as 2 plus 2, which is very obvious, dx. So I is going to be the integral of 2 over x minus 1 dx plus 1 half. This one is going to be, I can split this into two integrals. That is the integral of 2x plus 2 all divided by x squared plus 2x plus 5 dx plus 1 half the integral of 2 all over x squared plus 2x plus 5 all this dx. So I is going to be the integral of 2 over x minus 1 dx plus 1 half the integral of 2x plus 2 over x squared plus 2x plus 5 dx plus these 2 can come out in front, which will nullify the 2 and have the integral of 1 all over. This one can also be written as x plus 1 squared plus 4 dx. That is, this one is x squared plus 2x plus 1, which will add to the 4 here, making it plus 5. So which is the same as this one. I'm writing it that way because I'm going to express that as the arctan integral. So I is going to be the integral of 2 over x minus 1 dx plus 1 half the integral of 2x plus 2 all over x squared plus 2x plus 5 dx plus the integral of 1 all over x plus 1 squared, and 4 can be written as 2 squared dx. And really comparing this one to the arctan integral, we have the arctan integral, which is 1 all over x plus x squared plus what, a squared dx. Or I can say it like this, can do x minus p all squared plus a squared dx. And this one is the tan inverse, or the arctan, 1 over a of x plus b all over a. This is the arctan integral. So this one is the same as this, our arctan integral. That is the third one. So in that case, we can now wrap up our integral here. I is equals to, so integrating this one is 2 ln of x minus 1 plus 1 half. The differential of the denominator here is exactly the numerator. So in that case, the value of that integral is the ln of x squared plus 2x plus 5. This is a positive value, so it's a positive term, so you don't need to put it in absolute value terms. It's because of here, right? And this one plus, this is the arctan integral. This is the same as 1 all over 2 and the arctan of x plus 1 all over 2, and our 2 here is the a in this case, so plus the constant of integration. So this is the value of our integral. Therefore, we integrate, that is 3x squared plus 5x plus 8 divided by x minus 1 times x squared plus 2x plus 5, all this dx. This one is ever looking to 2 ln of x minus 1 plus 1 half ln of x squared plus 2x plus 5 plus 1 half the tan inverse of x plus 1 all over 2 plus the constant of integration. So this is the value of our integral. So if you really find this helpful, make sure to leave a thumbs up, subscribe to my channel for more engaging tutorials of integrals. I thank you so much for watching this video, and I will see you in the next one. Bye bye.